Hello everyone, welcome to my video. This time I want to explain about chi-square test. So the first thing that you want to ask before using this test is, what is the use of this test? So it's like to ask that, is your data or your observed data satisfy your assumption? And the example for this use of this test is, this is the simple example, is to ask, is your dice is fair or is your coin flip is fair? And for the dice, if the dice is fair, the distribution when you roll the dice must be 1/6, right? And for the coin must be half. And this is, so this test just used for categorical variable. This two example is categorical variable because for dice the category is like the side of the dice, and the for coin is like the side of the coin. There's two sides of the coin and there's 6 side of the dice. And even if they are fair, even if the dice or coin is fair, when you try to roll or flip them, the result must be not really exactly to 1/6 or half, right? So what we want to really know is how much, it's like how much imbalance is still balanced, or how much is deviation that is still tolerated. Yeah, like that. We talk about tolerance here. And this is the formula for chi-square test. This is the symbol of chi. So O here is the output or the observed data, and E here is your assumption. So in this example here, for the dice it must be 1/6, or for the coin flip it must be half. And for the dice here, there's a sigma symbol here, so there will be more than one operation here. So for the dice there will be 6, yes, 6, because there's 6 data. So for the dice it will be like, we test how many 1 that's out, how many 2, how many 3, and until how many 6. So there will be a 6 operation like this. And for the coin it will be just 2, because the side of the coin is just 2. So how many head and how many tail, like that. And this is the step-by-step using chi-square test. So first we must make a hypothesis, and for the dice case, here we use, for the dice case, the hypothesis is the dice must be fair, and the alternative hypothesis is dice is not fair. And for the coin is fair, and the alternative hypothesis is coin is not fair. And the second, we must define the alpha value. Alpha value is, this is just like a threshold, that if we surpass this alpha value, then we can reject this null hypothesis and we can accept the alternative hypothesis. And actually, when you using chi-square test, you must convert it to the p-value, so we can compare it with the alpha. And this is for the chi-square. In this chi-square there is a something like degree of freedom. Yes. So for the dice case, the degree of freedom is, because there is a 6 data, its degree of freedom is 5, and for the coin, the degree of freedom is only 1. The formula is the data minus 1, because there's a coin just 1, because the coin data is just 2, so minus 1 is only 1. So this is the simple example. Now let's practice with something like more complicated example. In this script, I using chi-square test to ask. Here I have a Titanic survivor data. There's a passenger ID. This is the status of survive. 0 for die and 1 for survive. This is a name, sex, age, and etc. And for this data, I want to ask if in this data, I want to ask that for the null hypothesis, let's say if the gender doesn't affect or independence for the survivability, and for the alternative hypothesis, the survivability is depend on the gender. Okay, so for the null hypothesis and for the alt hypothesis, yes, this is our null hypothesis and alternative hypothesis. I hope that I write it right. Here I already write the script. The purpose of this table is to convert from p value to the chi-square value. This table have shape like 100 times 10. This is to convert from p value to chi-square, where the column here is for the alpha value that we already defined. In our case, we will define it as 0.05, and for the row, it's the degree of the freedom, and in this case, the degree of the freedom is 1. So what value that we will grab from this table as the threshold to test our hypothesis is 0, 1, 2, 3, 4, 5, 6. Yes. This value 3.8. Okay, after that I read the data like this. I read two variables here, the gender and survivability, or the status of the survivor, either they survive or die. And here I count the total male, female, because the gender there is a 2, right? So the total male, female, total survive and diet, total male survive, female survive, male diet, and female diet. And what the use of this? to make it you understand, I will draw this. So in our case, there is a two variable, that is okay, survive and gender or sex. And if we draw it in the contingency table, it will be like this. Yes, it will be like this. So that's why in the script I write it like this. I want to fill this column. And actually, to determine the degree of freedom for two variables like this, the formula is like is this. So the row here is here and the column here is here, survive or diet. And because we only have two rows, will be like this. This is equal 1. After this, we calculate the expected value for each this column like this. So we calculate the expected value from male survive, female survive, male diet and female diet. So for each of this column there will be two values, that is observed and the expected value. And then for the expected value, the formula is, for example, male survive equal, it's equal the distribution of male times distribution of people survive times total data. And this is apply for the other three column. Yes, for the other three cells. For the female diet, it will be distribution of female in the data times distribution of people diet in the data times total data. This is the simple formula. Okay, back to the script. And now after we calculate all the expected value for the table, now this is the line for calculate the chi-square. So here we try to difference the total male survive minus expected male survive, and it will be powered by 2 and then divided by expected male survive. This is the same formula here. And then back to the script. As you can see here, there is a 4 value because we have 4 cells. And then after that we total all of them. And then after this is the line for we want to get the chi-squared for our alpha value that I previously explained. The coordinate is 0.6. And then after this, if our total chi here or total chi-squared here surpass the threshold chi, then we can reject the null hypothesis. We can reject the null hypothesis that is gender doesn't affect the survivability. I hope I write it right. And then we can accept the alternative hypothesis, gender affects survivability. But if this of the total chi doesn't surpass this threshold, then we fail to reject the null hypothesis. And then we can say the survival in Titanic is independent of the gender. So yeah, let's run this script and see what is the conclusion. Oh yeah, I forgot to save. Here, this is our threshold and this is our total chi-squared. And as you can see, this is surpass this value in the left, and then that's why we can reject the null hypothesis and accept the alternative hypothesis that survival in Titanic depends on the gender. If we just using this test, we don't know what gender that really can be more safe in Titanic. So to know that, I think we need to plot and here is the statistic from the survive and diet in Titanic. Here, as you can see, the percentage of male diet is few times bigger than female diet, and the survivability of female survive is, I think this is around 2 times than male survive. So there is a big gap in here, so it's really clear that if you see this graph, it's really clear that gender really affect your survivability in the Titanic. And I think that's all. Oh, there is one fact that actually in machine learning, this chi-square test is also used to do a feature selection like PCA. And as I already said that, but for this chi-square test, this is just apply for categorical variable. So I think we only use this for categorical variable like this, like survive or not, or gender, male or female, like this, dice, there's a 6 side of dice or coin. So yeah, that's all. Thank you for watching.